Hello, we are here back again with the next question, and the next question is see, let A be the set of all ordered pairs P and Q where P and Q are natural numbers, which follow or which satisfy this equation. The number of elements in our set A are. So see again, as I say, the natural way of thinking is you have P square minus Q square is equal to a number which is not that easily factorizable though. I mean, I think so. We won't be able to factorize it so easily, okay. But in LHS at least we are sure, no? A square minus B square. So you'll write, okay, A minus B into A plus B. Simple identity. Now, when it's an even number, in RHS it's an even number, we have to factorize it. How we start? See, 78. 78 means it's not divisible by 4, it's divisible by 2. So 2 into then what? See, not divisible by 4 means after 2 into it has to be an odd number. Though I can easily do it, of course, if I write it, so it will be what? 2 into 6 and then 1, 7, 2, 8, 3, 9, whatever. Okay. Now the interesting part. We have to find the number of such P and Q natural numbers which satisfy this equation. In LHS we have P minus Q into P plus Q. In RHS we have 2 into something. So of course both P plus Q and P minus Q must be integers. I think all of you will agree with that, isn't that, bachcho? They must be integers. Okay. So now what are the possibilities? See, either P is even, Q is odd. Now what do we get? In that case, what do we get? Both P plus Q and P minus Q are odd. Is it possible, bachcho? Is it possible that both P minus Q, because in that case, the product of two odd can't be even, so that can't be even. Whereas in RHS, we need an even number. Okay, so not possible. So this case is gone. Now the second case, what is it? Or, okay, P is even and Q is also even, or so either both P and Q are even. Now if both are even, what can we conclude? This implies P plus Q is also even, P minus Q will also be even. Now what about their product? So both are even. What does that mean? P plus Q into P minus Q. This should be a multiple of 4, whereas in RHS we have a multiple of 2, just a even number which is not a multiple of 4. Okay, then you may say, okay, what about that one more possibility, and that is both are odd. Won't we get the exactly same case? But if both are odd, both P and Q are odd, then what can we conclude from here? Then we will say again, sum of two odd is an even number, difference of two odd is also again an even number, and then again we concluded the same thing, P minus Q, and then we all again concluded that their product will be a multiple of 4. So what the answer we have then, bachcho? What's the answer? So the answer is number of elements in the set A. What is set A? The containing all such possible ordered pairs of P and Q should be 0. I think all of you will agree. Why? Because one is even, one is odd. Not possible. The LHS will be odd, whereas RHS is even. If both are even or both are odd, again not possible. Why? Because LHS is a multiple of 4, whereas RHS is a simple even number but not a multiple of 4. So that's it. Okay, so that was the next question. Now we will be taking up next question in our next video.